NoSQL databases have revolutionized the way we manage data in contemporary applications, offering flexible alternatives to traditional SQL databases. Each of these options brings its own unique advantages and disadvantages. So today, we'll explore these aspects to better understand where NoSQL really shines and, well, where it might fall short. So far, we've learned about NoSQL databases as this flexible alternative to the more traditional SQL setup, specifically focusing on the document data model, which uses JSON-like documents for dynamic data representation. We've also covered its scalability, its ability to handle diverse data structures, and some practical examples, like managing user profiles and product details. This document data model allows for complex data interactions without the usual constraints of fixed schemas, and indexing, well, that really optimizes performance. Ultimately, NoSQL offers a powerful approach to data management, enhancing innovation and adaptability for modern applications. Now, let's dive into the advantages and disadvantages of NoSQL databases. Now, let's see how we can efficiently insert multiple user profiles into a MongoDB database. The provided code demonstrates the use of the Insert Many function, which allows us to insert multiple documents into the user's collection in a single operation. In this example, we start by specifying an array of user objects, each with a unique user ID and name. This approach really highlights the flexibility of NoSQL databases because, unlike traditional databases, we don't need a predefined schema to dictate how our data should be structured. So, what does that mean for us? Well, it means we can easily add new users with varying attributes down the line, without having to deal with complex alterations to the database structure. Now, when we execute this command, MongoDB takes care of the insertion behind the scenes, ensuring that each user document is stored correctly. It's a method that's not only straightforward, but also super efficient, particularly when we're dealing with large volumes of data that need to be processed quickly, like when applications suddenly experience a spike in user activity. Overall, this code snippet really showcases the rapid and dynamic capabilities of NoSQL databases in managing user data seamlessly. Now, if we take a closer look, the top 4 bars, scalability at a whopping 90%, flexibility at 85%, high availability at 80%, and performance at 75%, are not just longer. They're also highlighted in one vibrant color. This clearly emphasizes that these attributes, well, they're scored really high and represent the core strengths of NoSQL systems. In contrast, the bottom 3 bars, showing lack of standardization at 40%, limited transaction support at 35%, and maturity and ecosystem at 30%, are noticeably shorter and displayed in a different color. This choice makes it crystal clear that these are the primary weaknesses. You can see that the visual ordering really makes the trade-offs explicit. There's a steep drop from those impressive performance-related strengths, hovering between 75 and 90%, down to the ecosystem and transactional limitations, which sit around 30 to 40%. So, what does this tell us? Well, it indicates that while NoSQL shines at scaling, flexibility, availability, and raw performance, it definitely tends to lag behind in standardization, transactional guarantees, and mature tooling. Now, the percentage labels at the end of each bar quantify these gaps, and they support the conclusion that, for use cases prioritizing scalability and flexible schemas, the advantages numerically outweigh the disadvantages. However, if you're working on applications that require strong transactions or standardized tooling, you'll definitely want to weigh those lower-scored categories carefully before diving in. Now, let's explore how we can represent an article in a NoSQL database using a JSON-like format. In this example, we're going to define a document that encapsulates all the essential details about an article, including its unique identifier, title, author, content, and associated tags. Each element in this structure really highlights the flexibility of NoSQL databases. The article ID serves as a primary key that uniquely identifies the article, while the title and author fields provide this structured metadata that can be easily queried. Now, the content field is where the magic happens. It allows for unstructured text, showcasing the NoSQL model's strength in handling diverse data types. Additionally, the tags array demonstrates how we can use the document model to group related keywords, enhancing our search capabilities. This approach allows for seamless modifications. If we find ourselves needing new metadata or content types in the future, we can simply add them without getting bogged down in complex migrations. It makes this structure so highly adaptable. Overall, this representation illustrates the power and convenience of using NoSQL databases for dynamic content management systems, where data can evolve along with the application itself. Now, let's see how we can retrieve an article from a MongoDB database efficiently. The code executes a query using the find_one method on the articles collection, specifically searching for an article with a unique identifier, article_ID, set to A001. This simple query is significant because it highlights the intuitive nature of NoSQL databases, allowing us to access precisely what we need without the complexities often associated with SQL databases, like intricate joins. By leveraging this straightforward syntax, developers can quickly obtain the relevant document, which not only improves retrieval speed, but also boosts productivity, since there's no need to define relationships through tables or worry about those pesky schema constraints you find in traditional SQL environments. This feature becomes particularly advantageous when managing hierarchical or nested data structures. It really allows for fast and flexible access to varied data types stored together in a single document. In summary, the ease of querying in NoSQL, especially through this MongoDB example, exemplifies one of the platform's major advantages, simplifying data interactions significantly. Now, let's take a look at a scenario in which user actions might lead to data inconsistency in a NoSQL database due to the eventual consistency model. So, in this example, user Alice adds an item to her shopping cart, which shows us how data gets updated in a NoSQL environment. Now, while this operation is happening, the update command is executed to ensure that item 123 is added to Alice's cart. However, due to this eventual consistency thing, there might be a little delay before other users, like user Bob, see that change reflected in their views of the data. Next, let's consider how user Bob queries Alice's shopping cart right after she adds that item. He retrieves that cart using a find operation, but here's the catch. There might be a lapse where Bob sees a version that does not show Alice's recent addition. This inconsistency really highlights the challenges developers face in NoSQL systems, where immediate data visibility isn't guaranteed. It's super important then to understand the use case and what levels of consistency are acceptable for different applications. Now, let's dive into how to manually back up a MongoDB collection, which is a crucial step for any NoSQL database management strategy. We're going to use a command that leverages MongoDump, a handy utility designed explicitly for creating backups of Mongo databases. So, to get started, we specify the database name with the -db option and input mydb, which, by the way, is the database we're aiming to back up. Now, the -out option is essential here. It directs the output to a specified folder on the server. In our case, it's set to -backup/mdb backup. Just imagine that folder as your safe deposit box, where all backup files will be stored, making it easy to access them when needed. By executing this command, you're essentially taking a snapshot of all the data in the specified database right at that moment. This manual backup method, while quite straightforward, underscores a vital aspect of NoSQL database management, the heavy reliance on command line tools for these important administrative tasks. Unlike many traditional SQL systems, which often showcase user-friendly graphical interfaces for operations, get ready for a little more hands-on coding here. So it's super critical to incorporate these practices into your workflow to ensure the safety and integrity of your data in your applications. Now, let's take a look at how we can model user data in a social network application using NoSQL, specifically within a document-oriented database like MongoDB. In our example, we represent a user as a JSON-like document that captures essential information, such as the user's unique ID and their name. Additionally, we include an array of friends, where each friend is also represented by a document that holds their own user ID and name. This structure allows for efficient retrieval, since we can quickly access a user's information along with their network of friends in a single query. However, while this model certainly provides advantages in terms of speed and ease of access, it also necessitates careful consideration when it comes to data updates. For example, if a user changes their friends list, those changes need to be reflected across all relevant documents, which could lead to data duplication and more complex operations. This highlights the importance of understanding how to strike a balance between performance and data consistency in NoSQL data modeling. Next, we will write a SQL-style transaction to demonstrate how data handling differs between traditional SQL databases and NoSQL systems. In SQL, transactions are really important for ensuring data integrity and consistency. So let's jump right in with a begin statement, which signals the start of a series of operations that should be treated as one complete unit. Now, we'll execute an insert command to add a new user to the users table, where we will specify the user's ID and name. This straightforward approach allows developers to ensure that the user data is added consistently, as no other changes can occur until this transaction is either committed or rolled back. Following up with a commit statement finalizes the transaction and applies those changes to the database. This example illustrates the relational model's strength in managing transactional data, which stands in stark contrast to NoSQL's approach, where transaction guarantees may not always be as robust. Understanding this transactional flow is crucial for developers transitioning from SQL to NoSQL, because they'll need to adapt to different concurrency controls and data management strategies in a NoSQL environment. To summarize, NoSQL databases come with a bunch of exciting advantages, like horizontal scalability, flexible data handling, and user-friendly querying capabilities. This makes them super well-suited for a wide range of modern applications. But of course, it's important to balance these pros with some of the cons, such as eventual consistency issues, limited tooling options, and the complexities of data modeling and learning curves. So, getting a grip on both the upsides and the downsides is key. It helps you make informed decisions on whether to dive into NoSQL technologies for your projects. By familiarizing yourself with these trade-offs, you'll be better equipped to innovate in the fast-changing world of data management. With all this knowledge, you're now ready to explore practical applications of NoSQL databases as you embark on your development journeys.